more than 0.03 amps, we can change that one also. We know that we never go negative on our current, so that one you can actually, you might want to leave it at a little bit of a negative so it kind of gets it up off the line. Just say 0.01. And now you can see where all of a sudden we're going to start applying a voltage to it. Keeps on going and stays at 0 amps. And all of a sudden you can see that then that diode starts to conduct. But then once it does start to conduct and it hits that 0.7 volts, which is right about here, then you can see that that line starts to shoot straight up. Okay.
So if you want to do it in reverse bias, Kurt, you got to plot it separate, right? You can't.
It is doing it in reverse bias. So let's just take a look at here. So here's our start and here's our end. So what we're telling it to do, so let's just go from the start. So what it's going to do is it's going to start at the negative 10 volts. So it's going to have the polarity across the power supply being this. Okay, so that's going to be, and that's going to give you your, here's your 10 volt source, and that's going to give you your negative voltage. So then you're always going to be reverse biased. Then what it's going to do is then it's going to start going the thing. So what it's going to do is go from negative 10 to a positive 10 with 100 samples. So somewhere in between there, it's going to, and so you can kind of see this is all the dots that I have. Then what it's going to do is it's going to go and then it's going to get to 0. It's going to plot that spot where 0 is right here. Then it's going to go to a positive 10, and then it's going to automatically change the polarities of your op amp to being this way. And then it's going to go into automatically go into a forward biasing. The only thing I wish this thing had, I wish it had cursors, you know, so that you could kind of figure out exactly what is at those spots. You know, like our bone plotter had the cursors and stuff. You know, we could actually pinpoint those. But if you wanted to kind of make that a little bit smoother, you know, we can change our samples so that it's doing more. So there's a couple different things we can do. So we kind of set up. We kind of rescaled our graph. Or what we can do is we can do the same thing without having to rescale our graph. What we can do is we can tell where to start. So we know that we don't want to, we know it's not going to probably go into reverse biasing, but we should probably at least take one sample of it, you know, go into the reverse biasing, go like negative 1 volt or something. And then we know that it's never going to go more than positive 0.7 volts, so we can bring that up to 1 volt. Then quick, oops, I can't do a lot here. So now it's going to do a lot more samples because my band isn't as more. Now you can see I have a lot more dots. It should have popped up. I don't know why it didn't.
This is the one you took over. Yeah, you can now turn into your IC. I had that one hooked up like that. Did you? Yeah. Just my way going through, I guess. Yeah, it was pretty good. You can test if you have your. Test if you have this open. But it's going to go this way or this way.
How did he adjust the scale?
You double click on the numbers on the bottom.
I don't know what happened to the light.
These numbers?
Yep, like right on the graph. You can click right on it, like where the corner is, and you can just type it in. If you need to change the sweep,
double click on the graph to the location.
Oh, I know. I pulled off my diode and tried something else with diode.
He was hitting
a diode in my thing here. So now I can go, so I know I don't have to go more than negative 1, and I don't have to go more than positive 1. Here's a plot.
This thing plugged in on set it up so you can
So
set
you're
your
zoomed
voltage
in when you click
on that.
No, mine's not
Like
zoomed in,
minus
like
two
Kurt was
volts.
I know, it does.
Really
like he double
So it's really zoomed in,
and then hit enter.
it's really
I'm
doing
dying,
something.
Kurt, come on, save my life.
Oh, what did you change your?
I didn't change
It's very really zoomed in. So what I just did is I switched it to, so I just put in the area that I wanted to zoom in on. So I only went to -1 to 1 volt because I know that's
I
the
just
only
changed my
region that this
values,
thing is
and it
active in.
Gives you a closer.
Yeah.
It's only active in that region, so I just kind of, a little bit before it, a little bit after it and stuff, then I can kind of zoom in. Then what I did then is I went ahead and then I can just go ahead and I can, if I do a right mouse button on here, I can set my graph to be auto scaling. So then when it was really zoomed in, and that's why I was jumping around, it's automatically auto scaling on there. And so I can set my graph to automatically auto scale.
Oh,
But this is one way of, verifying that this is, this is a good diode and, whereabouts is it actually being, where does it become active? So even at, I'm going to change that.
yeah, okay.
So you can kind of see now, I'm still doing the same amount of samples, but now it's only sampling it within that 1 volt. So now I'm getting 100 samples within that 1 volt range instead of the 20 volt range. So I'm also getting a higher resolution on there. And I wish I could, like I said, I wish you could identify what those voltages were on those points. But anyways, I want those cursors. So what I want you guys to do is when you're done with Tom's class, put the cursors in this VI. So. Then send me a copy of it.
Yeah. Well, we know how to get the program at least.
All right. So,
Change the color
oh,
of the
yeah,
LED,
yeah, yeah.
that help?
So what I want you to do now
Do I-
is just so you can see how that, so that we can really actually see how this is working. What I want you to do is I want you to hook up an LED to it, because the LED is a light emitting diode. But we have to be careful when we're actually working with actual early devices, especially an LED, is that we have to be careful that we don't exceed the current. Because this thing here doesn't know what kind of device we're using on it, so we have to be careful that we don't exceed the current limit of that device that we're testing. So what we're going to do is we're going to hook up our LED, doesn't matter if you're a red one or a green one, and we're going to put in what the specifications for the LED is. And here's our LED. I know that according to the specifications on my LED, I know it's going to drop somewhere around, we'll just for approximation, we're just going to say it's going to drop somewhere around 2 volts. So when that LED turns on and it lights up, and if I keep, no matter what I do with my voltage source, that LED is not going to drop anything more than 2 volts. I know that if I look on the specifications on this LED, that I can't have it exceed 40 milliamps. That's the current max I can have going across that LED. So we're going to just assume that my start, we're still going to go the -10 to 10 volts. We'll just say we keep it on the default of the diode characteristics curve. So what I need to do is I need to make sure that I never exceed 40 milliamps. So that when this thing starts to plot out, and it goes up to a positive 10 volts, that I don't exceed my current. I know the LED is going to drop 2 volts, right? So how much at my maximum voltage that my thing is going to put out, how much voltage is going to drop across my sense resistor? So we're going to assume that this thing is going to go all the way up to my positive 10 volts. Okay, so that's going to be my source voltage. This thing is going to go up to 10 volts. So how much voltage is going to drop across my sense resistor?
The remainder.
Yeah, 8 volts.
8 volts. Yep, it's going to drop the remainder amount. The LED is always going to take its voltage first. It's always going to drop its 2 volts, and then the remainder is going to drop across the sense wire. or a sense resistor, and that's going to be 8 volts. So what size resistor do I need in there then? What value of resistor would I have to put in there so that I never exceed my 40 milliamps? And how would I calculate it out? What would I need to do to figure that out?
You take your 2 volts across your LED and divide it by the peak current, and that would give you your peak ohms, or your minimum ohms, to keep below that 40 milliamps. So 2 divided by 0.04 is 50.
Okay, so remember, we're trying to find, you got it on the right track, but I'm going to help you out a little bit. So we were trying to find the resistor, right? So we're trying to find, there's always, we at least always try finding 3 things about the resistor, right? We're trying to find voltage, the current, and the voltage. Okay, so we already know our voltage, right? Do I know what the current is going through that resistor?
Figure it out.
What's that? Series circuit. So what remains constant in a series circuit? Current. So we know that if I don't have no more than 40 milliamps of current going through my diode, what's going to be my maximum current going through my resistor? 40 milliamps. Now, once I know 2 things, now I can find the third. So what size resistor would I have to have in there?
Ohms.
How much?
200 ohms.
200 ohms? So, yeah, so find,
200, not 220.
yeah, but you're not going to find a 200, you're jumping the gun. You're not going to find a 200 ohm resistor in your parts kit. But I think you should have a 220 ohm.
Yeah, you got
Yep, so you got to want, because I could either go to the 220, or I could go to the, what's my next one below that? 1.8, I think I have 180 ohm.
180.
Do I have 180 in there?
Yeah, so-
Okay, so my choices would be either 180 ohms or 220 ohms. If I go with a 180 ohm resistor, what's going to happen to my current going through my LED at 10 volts? It's going to go up higher than my 40 milliamps, right? So we always want to play it on the safe side, and we want to go with our 220.
You'll have a 150, so.
A 150, okay, then a 150, then we really don't want to go with a 150. So your 220 is going to be your ideal choice. So this is the kind of engineering that we do. So we have already, so somebody's already maybe came up with everything else, but we have to come up with, how do I come up with the test procedure for testing a new device? What is my device? Hey, I want you to test these devices. I want you to, because we can, this one here doesn't, but on the ones that you do out in the field, it's going to save that data. It's going to collect that data, and then so you're going to come up with a test procedure, collect that data, and then you're going to send it back off to the, to the engineer or whoever it is. But we're going to have to be the ones that we're the guys that are coming up. We're coming up. We're setting up the program. We might even we might write the program. We might do the program. We might do the hardware. We might have to come up with the data acquisition, and then we're going to have to come up with how am I going to set up that test procedure so that I don't ever exceed that current. So yeah. So now if we hook this up, and you hook it up to your LED, then you can actually watch what's going on with this variable power supply. Because what's going to happen is that LED is going to stay off, right? And then all of a sudden it's going to get up to approximately 2 volts now. And all of a sudden when it starts getting up to 2 volts, now that light's you're going to start seeing it get a little dimmer. Then it's going to get a little brighter and brighter. Then it's going to go really bright. So now you can actually see what's actually going on with these voltages here. But then once you get that LED going, this is why I wanted you to do that. This is the one thing I like about this particular VI curve tracer is that I can go ahead. I'm going to clear my plot so you can see it. This is why they don't have the cursors on there, because they want you to do this instead. But what I can do is I can adjust the applied voltage at any time. I can just go ahead and I can click on this and I can slide this. So like if I want to see what's really going on with my diode at, let's see, where's my, so right here, I'm gonna, so, this one I can't move, this is my voltage going across my, that's my voltage going across my diode, and so if I wanna set that up for, so that it's at, let's say, so I'm looking at my, here's the slider, but here's the voltage going across the diode, so I'm at 0.784, that's the maximum amount of voltage I can get on there. But if I want to kind of know what the current is before I get to that, bring it down. So I can actually move that slider around. So if I want to know what exactly is the current at that point of where that voltage of that diode is at 0.5, then I know I can figure out what the current is. It'll tell me what the power, the device power is, all that thing. So I can just kind of go ahead and I can slide this around and I can figure out what the current is. It'll tell me what the current is, what the resistance of that diode is. It's V divided by I, that's the resistance of your diode. So if you want to know, and so like if I start increasing it so that it starts conducting harder, meaning that it's going to be going up to a higher voltage, you can see that by look how my resistance really drops. If I'm below and I'm in my reverse biasing, I'm at about 18,000 kiloohms. Then as I start to conduct, and I really start to conduct it hard, then it goes from 18,000 kiloohms down to 30 ohms. But see if you can get that, see if you can get your diode and then go ahead and click your sweep and see if you can see that diode light up. And now the same thing goes true. Now make sure that you have the cathode on your ground. Make sure that you have that, watch your polarities of your diode. If you don't know what your lead lengths are, so if I'm looking at the diode, here's my diode, my side view of my diode, I'm going to have two lead lengths. One's going to be longer than the other. So what I want you to do is determine which one's your anode, which one's your cathode. And we can just do that doing our diode check. There's also, typically on, I can't remember if it's on the flat side or not, if somebody happens to cut your leads on your diode, if I look at the top side, not very good. There's going to be a little flat side on it. And that also indicates that it's either the cathode or the anode.
Negative.
So you need to determine which one's the anode and the cathode. So when you're looking at this stuff, you should be looking at, just don't go through the process of just doing it and getting, okay, now I got the graph and I'm going to pack up and go home. We should kind of take it to the next level. We should kind of understand, what is all these, why are all these things moving? What's this device power? Why is that doing what it's doing? The device voltage, we should kind of understand what is actually happening with our VI here. Kind of take a little bit further investigation into it, of what's all going on. Our device current, this is kind of our X and our Y, just kind of like, that's all part of our curve tracer. So you guys are working on your LEDs and stuff, so do you guys like the lab lecture type situation at this more atmosphere than?
Yeah.
We'll try doing a little bit more of it. I mean, I still want it to become, if we do it this way, if it becomes more of my lab, I want you to go. So we'll still kind of try getting you guys where you're working with each other and stuff like that and stuff. But at least so we can work through some of these hurdles where we're not just getting stuck on that and understand what's really going on. Because if nobody tells you what's going on, it's hard to kind of go, well, yeah, it's easy for me to look at it and I know what's going on. And I can't expect you to do that because you don't even know what kind of questions would I even ask myself to what's going on with these things. So, but I still want to make sure that it becomes more of your lab and not so much of the lecture. So, but I think this would be kind of nice if we can get everyone with some laptops and get everyone with computers and stuff. I think it'd be kind of interesting to give it a try and give it a whirl.
Oh, what's an LED? That's not an LED. Perfect.
Oh, anyone know what is that?
That's the lamp. That's at,
Oh yeah, I suppose I could show you what an LED looks like if we don't know what an LED is.
It's gotta be an LED.
oh, is that an
It's gotta be
LED?
an- it's gotta
Might
be
be
a
a
yeah,
better
it's a super bright LED.
Oh, wow.
That's something you bought?
Yeah, it's part of everything I got from my Arduino.
Oh, but it's from his Arduino, yeah,
Okay.
so find out then, so since you don't know what the specifications are, you know, run the curve tracer, did it work?
Launcher.
So it went into a reverse,
Yeah, just.
so did it change colors or did it do anything different when it went into reverse? You might have gone and started going into reverse breakdown, you might have been drawing more current than what it really wants to. Yeah. I didn't think we could even get that much current out of our.
You reprogrammed it, made it better.
Yeah. Yeah. Yep.
But I wonder, it's just because this is a different, this is bright.
Yeah, it's a super bright LED, but I'm still surprised that it went into a reverse, started drawing current on the reverse. But was it lit up when it was in the reverse? It was lit up this way, then it shut off, and then it started up right.
And then it ended at the end.
Really? So it's so it must be like a.
We had Gary.
That's interesting. That's another good idea. Take pictures of it with your camera and stuff. So you have to see that. I don't have any problems with that.
It's like
Probably being smart so that you know how to do it the next time.
The teacher, he's like.
Picture my flash drive get back.